Okay, good morning guys. So we're just going to spend a bit more time on substitution with elimination because everyone who submitted work in yesterday did it all via algebraic means. That just means we're going to stick to the algebraic rather than the bar models. So we will just crack on. So you'll probably notice there's something a little bit different today because yesterday I just had all positives, today I've also got negatives. But because I'm just teaching from one method, it should obviously take a lot shorter and you don't have to forward through the bar model if you don't want to watch it, because obviously we're just doing everything by algebraic. So let's just get on with it. We've got 4p plus 3q equals 15. This is my equation number 1. I then have p plus 3q equals -3. This is my equation number 2. So the first thing I do when I look at simultaneous equations is I see are any of the magnitudes, so just the size, is any of the sizes the same. So 4p and p obviously different because that's 4, that's 1, not the same, but I've got 3q and 3q, so the size is the same. Because they are both positive, the only way I can eliminate them is if I take one away from the other. So I'm going to do equation 1, take away equation 2. That will help me eliminate one of my variables, which in this case is 3q. So I'm going to do 4p, take away p is 3p. 3q, take away q is 0. And then you've got 15, take away -3, which is 18. Obviously, I've just put the 0 in there for your sake. You don't necessarily need to include it. Okay, so we've got 3p, I've got 18, so I need to divide both sides by 3. I've then got p equals 6. Okay, I'm then going to substitute this into one of these equations. I'm just choosing equation 2. So instead of p, I'm going to write 6. I'm going to keep it as 3q, and I'm going to say -3. So if I take away 6 from both sides, I then get 3q is -9. I've then got to divide it by 3 to find out what 1q is, which is -3. Okay, and then on the other side, I've got 4g take away 2h equals 12. I've got g plus 2h equals 8. This is my equation 1, this is my equation 2. Okay, so in this case, the magnitude of the 2h is exactly the same, but obviously one is negative, one is positive. The only way I can then eliminate this variable is if I add them together. So I'm going to add them together. So I've got 4g plus g is 5g. I've got -2 h plus 2h, which is just 0. And then I've got 12 plus 8, which is 20. Okay, so I've eliminated one of the variables. In some cases it will be this one, but in this case it's this one. Okay, so I've got 5g equals 20, divide both sides by 5, I then get g equals 4. When I found out what one of the variables is, we do need to substitute it back in. And the one that you usually substitute it back in when it comes to simultaneous equations, it's much easier to do it into the one that has positives than the one that has negatives. So if you do have a positive and a negative one, most people would opt for the positive. That way you don't fall into the trick of negative numbers, because quite a few people do. Okay, so I'm going to sub into 2. So instead of g, I'm going to put 4, and I'm going to have plus 2h equals 8. I then need to take away 4 from both sides, which then leaves me with 2h equals 4. I then need to divide by 2. That will give me h equals 2. Okay, so this is what happens if they've set it up and it's nice and easy and you already have a variable that's in place. So it's just a nice easy way that you can just eliminate the variables straight away. Okay, so this one, obviously a little bit different, where you've actually got no variable that is the same, so I just need to make it the same. So I have a choice. If I'm writing down these, I would still write them out as I would normally. So that's my equation 1, 3x take away 2y is my equation 2. Okay, so I'm looking at the magnitude, 4x, 3x. The only way I can make that the same is looking at lowest common multiple and saying the lowest common multiple for this is 12. So that means I need to change this one, but I also need to change the bottom one. So that's 2 equations I would have to change. And then for this one, the magnitude is 1y and this magnitude is 2y. So the way I can make them the same is if I only have to change one. So always choose the option that means that you change the less, because the more times you make changes to something, the more likely you are to insert an error. It just gives you more opportunities to insert an error. So for this one, you could multiply this one by 4, multiply this one by 3, and then when you've multiplied this by 4 and that by 3, it would still come out with the answer that you require. However, in this case, we do want to try and make it as easy as possible. So all I need to do is multiply this one by 2. So if I multiply it by 2, just to make this a 2y, I would multiply everything. You don't just multiply this, you multiply everything. So 4x times 2 is 8x, y times 2 is 2y, 26 times 2 is 52. I would then call this 1a. Okay, and then same as we did previously, I just look at these two and I say, well, the magnitude here is the same, what do I do to eliminate it? So in order to eliminate a minus 2 and a 2, I would have to add them together. So I'm going to say 2 plus 1a. Okay, so I've got 3x, 8x, which gives me 11x. This is 0. I've then got 25 and 52, which gives me 77. I then divide both sides by 11, so I get x equals 7. Okay, I'm then going to substitute that into the top one. So I'm going to sub into 1 because that's the one that's got loads of positives. So 4 times x, 4 times 7 is 28. 28 plus y is 26. Take away 28 from both sides, I then get y equals negative 2. That is my answer. Okay, for the second one, I've got 3u, take away 2w equals 38. I've then got 2u, take away w, which is 24. So that's my equation 1, equation 2. So again, just looking for what's the same, what isn't. These two magnitudes, the lowest common multiple is 6, so that means I have to change both of them. These two magnitudes, the lowest common multiple is 2, so I only have to change the bottom one. So I'm going to multiply this bottom one by 2, because it says 2w, and the only way to get 2w is to multiply the whole thing by 2. So 2u times 2 is 4u. W times 2 is 2w, and then I have 24 times 2, which is 48. This is my 2a. Now looking at the top and the bottom, I've got two negatives. So I've got a negative 2w there, negative 2w there. If I add them together, that's going to be negative 4w. So I don't want negative 4w, I want it to go to 0. So in order for it to go to 0, I would just take away one from the other. Okay, I'm going to do this one, take away this one, because this is the bigger u, so I want u to be positive. That's just the way I like working it. So I'm going to do 2a, take away 1. So 4u, take away 3u is u. This would just be 0. And then 48, take away 38 would just be 10. So you've already got what the answer is. So you've got u equals 10. Okay, both of these are negative, so that means we're just going to have to deal with the negative. I'm just going to sub into 2, because I've only got one w there, so it'll be nice and easy to find. So 2 times u is 20, 20 take away w is 24, and then I'm going to move to 20 that side, so I'm going to take away 20. So I've got negative w is 4, so that means w equals negative 4. Okay, so we've got both those answers there. And last but not least, okay, we're just going to look at this one. So this one would mean, so if you look at these ones, I've got 2x, take away 5y equals 1. I've then got 3x plus 4y equals 36. So I've got 1 there and I've got 2 there. Okay, so the 2 and the 3 lowest common multiple is 6, the 5 and the 4 lowest common multiple is 20. Okay, so for either which one, I would still have to change them. It doesn't matter whether I change the x or the y, it still works out to be exactly the same thing. And then I am just going to choose to do x, because I want to do x, okay? The reason why I'm just going to choose x in this case is because it's easier just to times that by 3 and times that by 2 than having to times everything by 4 and everything by 5. Because I like to try and work in as small as number as possible, because I can. So for this one, I need to times it by, so 2 needs to become 6, so I have to times it by 3. So I've got 6x. Then 5y times 3 is 15y, and then that equals 3. So this would be 1a. And then for this one, I'm going to times it by 2. So 3x times 2 is 6x, 4y times 2 is 8y, and then 36 times 2 is 72. This is my 2a. Okay, so when I'm looking at these, I can see there are two 6x's. The only way I could make them work is if I subtract one from the other. So I'm going to do 1a take away 2a. So I've got 6 take away 6, which is 0. I then have negative 15 take away the 8, which is negative 23y. And then I've got 3 take away 72, which is negative 69. So I am going to divide both sides by negative 23. That then leaves me with y equals 3. Okay, now I've got y equals 3, I'm going to substitute it back into this equation. So obviously I've got the negative and I've got the positive, so I'm going to pop it back into 2. So sub into 2. So I've got 3x, and then I've got 4 times this one, which is 12, equals 36. So 3x is going to equal 24. So take away 12 from both sides, divide this then by 3, I then get x equals 8. Okay? And then we have this one, which is 2g, take away 3h equals 3, that's my 1. And then I have 4h take away 3g equals negative 7, that's my 2. Okay, you will notice about this, it's something you should notice straight away, is that g and h are different ways around. So me personally, when I am doing this, I would automatically put the g underneath the g. It makes it easier for me to see what's going on. So I would say minus 3g plus 4h. And now when I'm looking at it, I can say lowest common multiple is 6, lowest common multiple is 12. Okay, so that works for me. So you just need to ensure that you find a method that works for you. I personally just know that if I have the same letters on top of each other, it makes it much easier when I'm multiplying and taking away or subtracting, because then I've got a bit of a column method going on. Okay, so for this one, again, I'm going to go for this because it goes to 6. This one I would have to times by 3, then times by 4. So this one I only have to times by 3 and times by 2, which is much easier to do for me. So to make 1a, I need to times this one by 3, and then I'm going to times this one by 2. So I've got 2g times 3, which is 6g. I've then got 3h times 2, which is... Sorry, I'm timing it by 3. Apologies. 9h. So 3 times 3 is 9, and then I've got 3 times 3 over there, which is 9. This is my 1a. And then for the second one, I am multiplying it by 2. So minus 3 times 2 is minus 6. Why am I writing minus 3 again? Minus 6. Minus 6g. And then 4 times 2 is 8h. And then negative 7 times 2 would be negative 14. Okay, so when I'm looking at this one, I'm saying, well, the 6's are the same, so how do I eliminate them? I have to add them together. Oh, sorry, this is 2h. So I'm going to add together 1a and 2a. Okay, so that becomes 0. Negative 9 plus 8 would be negative h. And then 9 and negative 14 would leave me with negative 5. So that means h equals 5. Okay, there are minuses in both of them, so it doesn't really matter which one I choose right now. I'm just going to go for number 1 because it was the first one. Sub into 1. Okay, so I've worked out h, I haven't worked out g. So it is 2g. Take away 3 times 5, which is 15 equals 3. So I need to add 15 to both sides, which then leaves me with 2g equals 18. Divide both sides by 2, g equals 9. Okay, so obviously they increase in difficulty. In the first one, you didn't actually have to change any of the sums. All you need to do is get used to them and then just subtract or add them together. For the second one, you changed one of the equations, and then obviously for this one, you just added the extra step by having to change both of them. So all I've done for each of them is just add another line, because all I'm doing is adding these lines. But otherwise, it's exactly the same methodology. You guys just need to be aware that when you change this line, because this was an error that I saw quite a bit, when you change this line, can you make sure you change every single term? If I'm timesing it by 2, I need to change every single term. When you add or take away, you're doing it from two sides of the balance. So if I had to take away 4, I look on one side of the equals, take away 4, I look on the other side of the equals and take away 4. But if I'm multiplying or dividing, I have to look at every single term. I don't just multiply one term and leave it be. I have to multiply this one, I have to multiply this one, and I have to multiply this one. So I have to multiply all 3. This is where a lot of you were making mistakes yesterday, so you need to ensure you keep on top of that. That is a basic equation skill. That isn't even a simultaneous equation skill. That is just your basic linear equations. You should remember how to do that. Okay? So I'm going to leave it here. I will be posting some stuff, so obviously I'll get the sheet onto Google Classroom for you to do. Obviously I want a good amount of work. If you do submit without work, I will be returning it straight back. If you only submit about 4, 5, 6 questions, I will be submitting it straight back. You have more than enough time to work out at least the bare minimum 8 questions, and that does not include these examples. I would expect you to write down the examples just so you know the methodology that you need to use. Okay? Take care, guys. Obviously, any questions, you need to let me know. If you're not communicating with me, then all I can do is assume that everyone knows what they're doing. So you need to ensure that you do communicate with me. Okay? Take care. Stay safe. Make sure you get some vitamin D, especially with the sun coming out now. Okay, toodles.